Why did this man fall? Is it due to his lack of knowledge of the surrounding, or is it due to gravity? Well, the answer is both, but gravity had a bigger part in it. See, without gravity, he would have just been floating around in space. We wouldn't be able to do anything. Gravity is everywhere. It keeps us attached to this earth. We have to overcome the force of gravity in order to go high, high, and higher. Without gravity, there won't be a base to construct. So gravity does limit our construction, but it also allows us to build.
It is important to know what gravity is, so we know how hard you can fall. So truthfully, I'll talk seriously right now. It is important to know gravity because it is the force that's always acting upon you. To be precise, it is 9.8 meters per second squared. That's the force of gravity. And with this, we have created multiple equations like the force of gravity equation, Fg equals mg, g being 9.8 meters per second squared, like I said before, and the potential equation, which is mgh, so mass times gravity times height. So it is important to know these equations because engineers and builders need it in order to build structures.
Gravity is always pushing us down to Earth, and so our buildings and houses that we make are always having a force upon them that's pulling them down. And as we increase in layers, the force of gravity on those floors stacks up. And this is important for builders and engineers because they need to know how strong their building can support, how much weight they can take, and what the materials they need. So let's take, for example, if we can manipulate gravity. We can make the force smaller, and so our constructions will be easier to make as they won't have much force acting upon it and they won't break easily. So the moon is a good example, and other planets with a different gravity, a much smaller gravity than Earth. We can jump higher on the moon, so we'll be able to build higher on the moon too, quite easily.
In the current period of time, we're not able to manipulate gravity just yet with our current technology. Speaking about technology, it has changed throughout history immensely. Let's take a look at those effects on our constructions.
Let's take a look at these changes throughout history. Well, first we had the pyramids of the ancient age. And those pyramids stood around 138 meters tall. And they were the tallest structures man had made for hundreds of years. And then came the churches in New England, which stood over 150 meters tall. And those lasted for a few decades, but then were overcome by buildings and skyscrapers in 2015 that stood over 800 meters high.
So, what does this all relate to? This all relates to the advance of technology. Back in the time of the pyramids, they had no electricity or machinery in that time. They used sand and animal to lift heavy stones up to where they were supposed to be placed.
When the church came, they had more advances in like the pulleys and simple machine, and they had metal tools that were stronger than before and were able to have precise construction stones and height that they could carry on to. And now in today's age we have electricity, heavy machinery, drills, and all those kind of things that they didn't have before that can help make glass structures stand 800 meters tall. We have the Eiffel Tower, a magnificent construction. Now here we have the Empire State Building, a really, really, really tall building. Now we have Mount Everest. One of the natural wonders of the world. Mount Everest, the Eiffel Tower, and the Empire State Building. This scale isn't real. Clearly, Mount Everest is much, much taller than both of these. Mount Everest stands at 8.8 kilometers high, while these two buildings don't even reach 1 kilometer, half a kilometer.
Okay, now for my part. What if I were to tell you that buildings could actually reach the height of a mountain like Mount Everest? The reason why I say this is because structures such as the Burj Khalifa is made of 85% air and only 15% structure. So, talking hypothetically, we can actually build structures 6.67 times taller than mountains, and that building will have the same mass as the same mountain. Since we cannot make the base of a structure as wide as a mountain's, we have to make it skinny and tall. So in order to be able to do this, the materials must be able to handle the force of gravity downwards. But as we increase the height, the force of gravity will also increase and affect the top layer substantially. So in order to use the right material, we're thinking about using carbon fiber tubes. But the problem with carbon fiber tubes is the cost. How it costs millions of dollars. But carbon fiber tubes are really strong in the atomic level and will not break very easily. Look how elegant this Empire State Building looks like. Compared to the older structures created by man, like the pyramids, which are made out of stones, or other structures made out of wood. Now, just imagine, what if we had more advanced technology like carbon fiber? We'd be able to make structures that go as high as into space. Major structural problems with this, buildings as high as this, is that we don't have a strong foundation or resources or the elevator speed. Now I'm going to talk about specifics here. The thing about strong foundations, you'll need a lot of resources to make a strong foundation like a mountain's. And a single country is not willing to pay the bills to do that because of financial problems they might have. Another thing is elevator. People can only withstand an elevator speed of 38 miles per hour. Any more and our ears couldn't handle the pressure. Any smaller than 38 miles per hour, it would take a really long time to go on an elevator to the height of the structure.
So we also have to consider natural disasters. When we have really tall structures, the forces of wind, earthquakes, they all come into factor and they can easily destroy these structures. So we need strong materials, the right physics that can withstand such earthquakes and magnitudes that are higher than 5. And so engineers and builders have to take that into consideration. And when we talk about materials, we're talking about the type of glass, cement, concrete, and all that kind of things, wood. We have to take that into factor as how much it costs and how strong it is. Right now we've covered some problems that we can face, some solutions that we might have. And we also covered the changes in technology in the past. But now let's talk about the future. We kind of covered that with manipulating gravity, but we haven't looked at computers and softwares themselves, 3D programs that can run simulations, real physics simulations, that can prove that if this building will stand or it will fall in certain situations. They can manipulate earthquakes in the computer, wind, heavy winds. They can see what materials are right for this building, what materials aren't. They can see how high this building can stand on its own. They can see how will it fall and where will it fall. Here's an example. Blender 3D. It's a physics rendering software where you can make games, building designs, blueprints, you name it. You can do anything in that software. It has something called Blender Bullet Physics, which basically is like our real physics, where once you know how to program it, you'll be able to create real-life situations. Why are these 3D softwares important? Well, these 3D softwares have changed from like the 21st century, so we are able to now experiment with new building designs in the virtual world, and these actually prevent some disasters from happening. So let's say you'd had a building design in the software, and you didn't know how strong it was. Then you simulated everything possible, and you noticed that an earthquake of magnitude 4 made it crack and it gets ruined. And now you found an error in some of the materials in glass, and you could fix that, and then see how it would test out again after you fixed it in your design. And then you could build it in real life.
Going back to our question on how high we can build, our limit would be the thermosphere.
So the thermosphere is 85 kilometers high. Now we don't have any construction that can reach it yet, but we do, hypothetically speaking, have the materials, which is carbon fiber tubes. And those materials cost a lot, and no one is prepared to build and manufacture those resources to make a construction that's 85 kilometers high. Once you pass the thermosphere, you'll get into the range of satellites and other objects that we send in space. not exactly at 85 kilometers, but higher than that. And once we get into that thermosphere, you're practically in space. And after a certain point, gravity will now not be pushing down, but to centripetal acceleration, because the building is rotating with the Earth. The gravity will actually, the centripetal acceleration will actually push the top layers above into outer space. And so we get into a whole new kind of problems and situations. So right now our limit is the thermosphere, if we can actually manufacture resources and get that high.